Our second major category of rocks are sedimentary. The learning objectives, I haven't been reading to you all because I thought that you would understand the importance of them. But I'm going to make an exception here. Outline the major steps involved in sediments becoming sedimentary rocks. It doesn't just happen automatically. List Earth's depositional environments and clues found in sedimentary rocks to these environments. So we'll talk about what those depositional environments are, and they're very important. Describe the difference between clastic. Sometimes these will be referred to as detrital. I hate it when so many words are used for the same thing because, especially in introductory classes, I think it can be very confusing. And chemical and biochemical sedimentary rocks. Identify sedimentary rocks from each category and summarize the clues that are found in sedimentary rocks to past Earth environments. That's why sedimentary rocks are so cool. For example, cross-bedding, ripple marks, graded beds, transgressive and regressive rock strata. That refers to rocks that show us whether sea level has been increasing or sea level has been decreasing. This is our old friend, the rock cycle. Anytime a rock is exposed at the surface, we already talked about how weathering can occur. So those sediments end up being transported by wind, water, ice, or gravity, and at some point they have to come to rest, right? So deposition occurs. And then these things have to happen to the sediments. They have to be lithified, and we'll talk about what the steps are involved in that to become sedimentary rocks. So we've talked about our igneous rocks, the intrusive and the extrusive. And now we're here. We've discussed weathering already, the different types of weathering, and that's going to be important when we talk about the categories of sedimentary rocks. And then here we are, and our last category of rocks will be metamorphic rocks. So sedimentary rocks are formed from the weathered and eroded remains of rocks of Earth's crust. This is a very good exposure of sedimentary rocks here in the Grand Canyon. And one of the characteristics that you see here is layering. See all of these layers, layer after layer, like a big old layer cake. That is one of the telltale signs of sedimentary rocks. And these layers we call strata. Strata is from the Latin word for, guess what, layers. And one of the things that we see going on here in this picture is weathering and erosion taking place. Look at this river down here, how muddy it is. So we've got transportation of sediment. So we have sedimentary rocks that have formed here, and we have the processes going on down here to form more sedimentary rocks. Rachel Carson, a famous author that wrote Silent Spring, she said, "In every grain of sand is a story of Earth." And that's very true, especially when we're talking about sedimentary rocks. So why should we study sedimentary rocks? Many reasons. They reflect the physical and chemical characteristics of source environments, and those source environments could have been from 1 billion years ago. They contain direct and indirect evidence of life. It's mainly sedimentary rocks where we find fossils. There are a couple of exceptions to that. Some metamorphic rocks will have fossils in them, but for the most part, burial and heat and pressure will destroy the fossil evidence. And then there are some fossils that are found in igneous rocks, especially volcanic ash. But for the most part, fossils are going to be found in sedimentary rocks. So they can be interpreted to recreate Earth history. They're the source of all fossil fuels, and they cover more than 75% of land surface. So there are lots of sedimentary rocks out there, referred to as the icing on the cake. Well, here are the first steps in forming sedimentary rocks. Weathering and erosion. Weathering and erosion will produce the clastic sediments and the chemical or biochemical sediments that we discussed in the last chapter. Then those sediments have to be transported. And the agents of transportation are gravity in the form of mass wasting, wind, water, and ice. And then they will come to rest in what we call a depositional environment. And they can be many different things, from a beach to a lake bottom to an ocean bottom. Well, some of this is going to sound familiar to you because the types of sediment go back to the weathering chapter. How does the weathering take place? Is it physical weathering, or sorry, we called it mechanical weathering. Is it mechanical weathering or is it chemical weathering? So those sediments that are derived from mechanical weathering will be these solid particles of different sizes. Remember boulders, cobbles, pebbles, sand, silt, clay? So it's just rocks that have become smaller. Chemical and biochemical sediment, that's from minerals that will precipitate from solution, or the minerals that organisms extract from water, either ocean water, lake water, river water, to build their shells, and then from plant material. Once those organisms die and their little carcasses float to the bottom of whatever water body they're living in, they will get compacted and transformed into sedimentary rocks. Same thing with plant material in the case of coal beds, C-O-A-L, coal. So any rock that is formed from sediments is called a sedimentary rock. And here are some examples of clastic sediments. You see all the different particle sizes here. So these would be more like pebbles. These are cobbles. This, of course, is sand. And then these are some of those smaller particles. Silt, there could be some clay in here. These look like they could be clay banks right here. So those are being transported in the water column, in this stream that's flowing through here. Clastic fragments. This slide shows chemical sediments, as we see here in this picture. This is a dried lake bed, or the term that we use is a playa. The water has dried up and the minerals that were in the water have precipitated out. So those are chemical sediments. These are biochemical sediments. See the little shell fragments in here? Those are from an organism, so biochemical. And then coal is formed from plant material that has become compressed, compacted, and it turns eventually to a rock called coal. These are sedimentary rock beds. These are the layers, again, very distinct characteristic of sedimentary rocks. And you see how we have different thicknesses in these layers. The composition is different, the texture is different. All of these represent different time periods in Earth's history. And since we don't see any major faults that have happened here, the ones on the bottom are going to be older than the ones as we get higher, until we come to the very youngest material at the top. See the different colors in here representing different chemical reactions that have taken place with the, within the rocks. Once the sediments are formed, they begin to move. And they can be moved by water, and it can be running water like in a river or a stream, or it can be ocean waves or marine currents. It can be glaciers. Glaciers are nothing but icy bulldozers. And winds can move sediments, and also gravity. All of these above we have to have gravity involved here, but there's a specific type of geologic process called mass wasting where gravity is the instigator of it, and that's in a different chapter, but we'll get to that later. The faster the transport speed, and this just makes common sense, the faster the transport speed, the larger the particle size that the water or the glacier can move. Current strength is going to be related to the current velocity, and that velocity will determine the size of the particle that can be picked up and moved. Just makes sense. The stronger the current, the larger the particle that it can move. So currents might start out and they're carrying all different sizes of sediments, but as the strength changes over time, these particles will be dropped out successively. The larger ones, then the smaller ones, until we get to the very tiniest of particles. And a good example of that would be in the basin and range areas where we have these deserts and we have high mountains that are separated by these low areas. And in the summertime especially, we get these big thunderstorms that brew, and all this water begins to pour out of these mountains at very high speeds because the mountains are steep, so very high speeds. And then that water abruptly hits these flatter areas. So that speed of the current is going to decrease. And when that happens, the larger particles are dropped out. And then the current continues to move on out, and the speed continues to decrease. So then we would see these particles become smaller. And then way out here in the flat area, the really flat area, and I know I made it all look flat, but that's just because I can't draw worth a hoot, we would get the very smaller particles, the sand, the silts, and the clay. So it has transitioned, the particle size has transitioned as the speed of the current decreases. This is an example of a weak current. A gently flowing stream. If there's anything being carried in the water column here, it's going to be the very finest of particles, maybe some clay particles that are being carried along. And then this would be a moderate current. We might have some silt in here, maybe even some sand in here that's being carried along. And then strong water currents. So all particle sizes are being carried in the water column itself. We might have some things being carried along the bottom of the channel. So strong currents can carry boulders, cobbles, and pebbles, along with the smaller particles. Moderately strong, mostly rivers, can carry sand and deposit sand along their channels. Maybe if you're fishing or you canoe or anything, you've seen sandbars along the river. Sometimes the particles are larger. Sometimes there can be gravel bars along the river. It just depends on the speed that the river has been flowing. Rapidly flowing water can spread sand over the entire width of a river valley, the floodplain of the river. Especially in flood stage, when the river recedes, then all that material is left behind. Waves and currents will deposit sand on beaches and in the ocean, and wind will blow in deserts and it will deposit sand. Air, though, is less dense than water, so it requires a higher velocity to move the sand. And then weak currents will carry muds composed of silt and clay, the two smallest of our particle sizes. So here we have a glacier, and notice the color of this glacier. sometimes we think of glaciers as being just this pristine white, but they're not, because they're carrying every size particle in here. As I said before, they're icy bulldozers. Here's the edge right here of a big particle that's carrying. But all this material that is settling down on the glacier from maybe any pollution in the air, but lots of different particle sizes that it's carrying, chewing up as it goes along. Then here's sand being carried on a beach, so the wind has kicked up. And then here's sand in a desert. This is a sand dune, and we see that wind's blowing off the sand dune. That's why sand dunes move. They're migratory because of the fact that the wind is always blowing them. Let me just draw a sand dune here. And we see that this is how, if you could look at the cross-section of sand dune, it looks something like this, because they're constantly moving. There's no plant material to hold them in place. It's just loose sand grains. So all the sediments that get carried along will collide with other sediments. Eventually, they will abrade, and rounding will remove the edges. Remember, when they are weathered, they start out as angular edges, but over time those angular edges will be subdued so that we get more rounded material. Sorting will occur, as we talked about before, as the speed of the current changes. Well-sorted particles are close to the same size. Poorly sorted, you would have a range of all the particle sizes, all the sediment sizes that have been dumped out. A glacier is good at doing that. Actually, a glacier is good at doing both of these. Depends on whether there's water involved or whether the ice just melts in place and everything gets dumped out that was embedded in the ice. Those would be very poorly sorted. So we say rounding of particles, but rounding doesn't necessarily mean that they have to be round. But we know that these started off as more blocky, and we see what has happened to these. I mean, think of any of the rocks that you've ever found along a riverbank. They're not square, are they? They're all rounded, nicely rounded particles. And then here's, this one is oblong, so we wouldn't call that round, but we certainly see that it's no longer angular. So abrasion has caused these to take on these particular appearances. Then sorting, the particles will be separated based on the density of the particles. So here we see that the sand has been sorted and most of the particles are the same size. So we've got very good sorting here, and the particles are small. And here in this stream, we've got different sizes of these particles, but we see that most of the sizes are much larger than what the wind would be able to carry. It would have to be a hellacious wind to be picking up rocks this size, wouldn't it? And what would you say this picture shows? Would you say it would be poorly sorted or well sorted? And I hope you said poorly sorted, because we have all different sizes in here. We have some smaller fragments in here, and then we have some larger ones. So that is a poorly sorted example. These, look at these. These are all angular in size, so they haven't been moved very far from their source region. They haven't had time to become rounded. And for the most part, they look like they're pretty well sorted. They're all pretty large. The particle size will reflect the environmental energy. What was the energy of the wind, water, or ice? So this is in your PowerPoint notes, so I won't read all this whole table to you, but just to point out a few things. The sedimentary environment, look at these. Dune, ocean beach, wetland, stream channel, glacier, steep hillside. The transportation process. Well, we know what the transportation process is going to be here. Wind, waves, currents, wind on a beach, wetland, weakly circulated water, maybe some wind. Wetlands are going to be flat. Stream channel, running water would be the transportation process. Glacier, ice is the transportation process. Steep hillside, that would be mass wasting. So this is where gravity is going to be the major factor behind why something is moving. Then you can look at the different sediment sizes, sorting, whether the sorting is very strong or whether it's weak, and abrasion, what's that degree of roundedness. And I'm going to stop here, and I will see you next time for depositional environments.